Okay, in the last section, we'll talk about reviews and inspections. So in this part, we will talk about software audits, which is related to reviews and inspections. So what is the first look at what is a software audit? Okay, so according to the ISO 9000 standards, so ISO 9000 is general standards for quality for all products, not just software product, for all products. Okay, it's a set of standards. So what is audit? So this definition applies to audit products. Okay, so audit is a systematic, independent, and documented process. So this process is to obtain evidence and objectively evaluate this evidence to determine the extent to which criteria are met. Right? So basically, audit is to check the evidence against some criteria. Right? So first, what's criteria? Criteria is a set of policies, procedures, and requirements used as references against which objective evidence is compared as criteria. Okay, so criteria can be, for example, the standard process, and also the quality standards defined by some international standards. Okay, and what is evidence? Evidence is the records a statement of fact or other verifiable information that is relevant to the audit criteria. For example, the evidence can be the documentation of our process, the source code, the styles, and the follow the process when developing the source code as evidence. Okay, so we check the evidence against the criteria. If the evidence follows the criteria, meets the criteria, we say the audit is successful. And if the evidence doesn't meet the criteria, we say the audit result is a failure. So you need to improve your process or product. Okay, so that is the definition of audit. So we can consider it as the most formal form of reviews. It's the most formal form of reviews. Okay. So what we can do using software audits? So we can use it from different perspectives. First is to check compliance with standards. So we want to determine whether our process follows the standards. Okay, so the standards is a criteria. Second is check compliance with a model such as CMMI. CMMI is a model to improve the software development process. Okay, the CMMI is a criteria. Okay, and the third perspective is to verify the compliance of this project process and progress with approved plan. Here, approved plan is a criteria. We want to check the progress and process against the approved plan. Okay, so that's the different perspectives of software audits. So there are usually three types of software audits. The first one, internal audits, so which means is for the organization itself to audit its developed software. So it's internal audits. So it's usually like a self-declaration. For example, I want to tell other people. So our organization want to tell other people that so our process, our software product meets some standards. So we need an internal audits before we can say that, right? And the second is second-party audits. So this audit is conducted by a second party. So who is a second party? Usually it's our clients, our customer, our users. So they are the second party of our audit process. So they can be our client themselves, or they can be the parties hired by the clients. Okay, this is second party audits. Third party audits is conducted by a third party. For example, by the government or other organizations, so who have experts in software auditing, who understand the standards or the process. Okay. So third-party audits sometimes can bring us a certification. For example, we want to say our software development follow some standard process, and we want to get a certification for that standards. So we need a third party to verify our process and our product to ensure that everything follow the standards. That is a third party audit. Okay. When we talk about audits, we need to talk about the ISO 9001 standards. So this standard has made quality audits popular. Okay, we say, so when we do audit, we want to verify against some criteria. So ISO 9001 is a standard criteria. Okay, so what is this standard? So let's first look at ISO 9000 standards. It's a set of standards. It's the international set of standards used in the development of quality management systems in all industries. The quality management systems you can consider as a quality assurance system. Okay, it's for all industries, not just for software industry. Okay, so ISO 9001 is the most general of these standards. It applies to organizations that design, develop, and maintain products, including software. So ISO 9001 is the most general of the ISO 9000 standards. Okay. As we say, the ISO 9001 standard can be used to develop software standards. It is not a software standard. It can be used to develop software standards. Okay. And basically, this standard tells an organization what to do, but not how to do it. For example, it tells the organization that design reviews should be performed, but it doesn't say how exactly to organize such reviews. So this is the general ISO 9001 standard. Okay, let's look at what are the contents in this standard, right? So the content of this standard can be divided into two parts. The first part is a product delivery process. It's about how we build our system, how we deliver our system. For example, it includes the standard for testing. You need to test your system, and you need to support your system. And you need to follow some process to design and develop your system. Okay, that's a product delivery process. So it tells what you should do, but not how to do. Second part is supporting processes. So how you should support the product delivery process. So what are supporting processes? For example, your business management, your supplier management, configuration management, and the inventory management. So you need to have this supporting process to support the delivery of our products. They also tell what you should do, but not how you should do. Okay, so these are the core process of this standard. So this is the most general form of software. Sorry, not software. It's a general form of a quality standards for all products, right? So they also provide a certification. If you are ISO 9001 certified, you may attract more customers because the customers believe in this standard, and you may So they may believe in your product. Okay, so how to get this certification? So you must document how your processes are related to the core processes defined by the standard, the 9 core processes. Okay, and you also need to define and maintain the records. This record should demonstrate that the defined organization process have been followed, right? And also, you need to have a company's quality manual, so which is for software is a software quality assurance plan, right? So you need to have this manual to describe the relevant process and the process data that has to be connected and maintained. So you need to have all these 3 in order to get this ISO 9001 certified. Okay. So here we it outlines how you can follow this ISO 9001 standards. So ISO 9001, they have a quality model. Based on this quality model, your organization need to define quality manual. For software, is software quality assurance plan. Okay, for the organization. For example, for next year, how you should do quality assurance for your software products. That's a quality plan, right? And for each specific project, you need to have a quality plan for this project. So that quality plan is what, for example, what we're writing for our assignment 1, right? So you need to have quality plans for each project. So based on this process, you follow this ISO 9001 standard. And then you can get certified by the 9001, ISO 9001 standard, okay? So this is how you should do to get certified, but there should be a process to do the certification itself, right? So first, you already followed the process and you have an organization quality manual, right? And there should be an independent accreditation authority or audit authority to verify your process, to verify what is recorded in your data. So in order to give you this certification. Okay. That is the ISO 9001 standard. So there's a brief discussion. Do you think that the quality of the software produced by ISO 9001 certified companies will always be better than that from uncertified companies? Just brief think about it. Okay, so does anyone want to tell your opinion? Okay, let's look at so one perspective. Okay, the standards, the ISO 9001 certification is inadequate because it defines quality to be the conformance to the standards. It tells what you should do, but not how you should do, right? So you may, for example, you may fulfill the standard requirements of the standards. For example, the quality standard may ask that your test coverage should be 80%, right? So you can design your system, your process to fulfill this coverage requirement. You can have an 80% coverage, but you may design some low quality test cases just to reach this coverage requirement. So which may not help improve the actual quality of your system. Okay, right? So this example shows that even you can be ISO 9001 certified, but the certification doesn't mean you can deliver high quality software. It doesn't guarantee high quality software. Okay. So talk about this standard. This standard is not about software, it's about all products. Okay. So there's another standard, ISO 9000-3 standard. So basically, this is a extension of the ISO 9001 standard, and it focuses on software standards, software quality. So we don't go to details of this standard, but you need to understand that ISO 9000-3 is a specific application of ISO 9001 standard in software. Okay. And ISO 9000-3 standard defines things related to software audits. For internal audits, it defines that so when software development organization plan their development program, they also should have a planning for their audit. Okay, they should have a plan for their internal audit. So the internal audit should select projects to cover all the development lifecycle process for each phase. For example, you can choose, for example, your organization may develop 5 software projects in the next year. So you may choose 4 of them in the audit process, and each software project may cover 1 development phase. For example, for one project, you cover the design phase. For another project, you cover the development phase, and for the third project, you cover the quality assurance part, right? So you should cover all the development lifecycle process using your selected projects. So that's the requirements for internal audit, right? And in order to be ISO 9001 certified, as we mentioned, an independent audit will need to be performed. We need to have an external party to audit our software development in order to be ISO 9001 certified. So what are the steps for the third party or external audit, right? So this process is conducted by a third party, by an independent party. The first step is to select assessors. So they need to select a group of experts to assess whether our software development process follow the standard, right? And they need to find those experts and need to interview those experts. That's a choice of assessors. The second part is they have some meetings and questionnaires to get a preliminary understanding of the audit organization. So they want to audit our organization. They need to have some interviews, meetings, questionnaires to have some understanding of the projects in our organization and our software quality assurance process. Okay, and also the third step. So they need to have an analysis of the questionnaire answers, and also they have to review the documents of our organization to have a deeper understanding of the process followed by the organization. Okay, this is the third step. The fourth step. So then we have site review, site visits to visit the campus of our organization. So they may have some interviews with some of our colleagues to ask some questions regarding our process, our policies. And they may make some presentations to help us understand the auditing process. Okay, and the fifth step, so they will have the findings from the interviews and from reviewing the documents. So this findings will be then be validated, and they will produce a final report at last. Okay, so this is the process of the external software audit. And what is the result of the audit, right? So what are the audit findings? So the result is an evaluation of the collected audit evidence against the audit criteria. Remember, the evidence are the interview results, are the results of reviewing the documents, right? Are the questionnaires. They have this evidence. So they verify this evidence against the criteria. The criteria is documented in the ISO 9001 standard. So they compare these two, and they have their findings. So they will either indicate conformity or non-conformity of our process. So the conformity means we pass this audit and we will get a certification. A non-conformity means we don't pass the audit. Okay. So audit findings also can lead to improvement opportunities or identification of good practices or improvement opportunities. Right? So these are the findings of audit. Okay. So based on the findings of the audit, so we can take some actions to improve our process. Right? There are basically two types of actions. The first one is corrective actions. So we want to eliminate the cause of a non-conformity and to prevent the recurrence of this non-conformity. That's corrective action. We also have a preventive action. So that is to ensure the future performance of a project, to ensure in the future we can have less non-conformity. Okay. So what is the role of SQA team in this auditing process, right? So the SQA team should monitor performance of corrective actions. So we should, if the developers, they don't want to take corrective actions, so we should be able to enforce the performance of the actions. We have different levels to enforce the actions. First level, so we can contact the project leader, right? Second level, contact the development manager. Third level, we can contact higher management, right? So the SQA team should be able to enforce the corrective actions. Okay. So we talk about these theories and this process to be followed. Let's look at one example, okay, to have a better understanding. So this is a case study of a small organization called a VSE. So VSE is a startup company from Peru. So they want to be ISO 9001 certified. So this company was founded in 2012, and they only had 4 employees at that time. Okay. So this certification process was performed in 2 stages by a Brazilian register, third-party auditor. Okay. The first step cost $1,000, and the VSE investigated 22 hours to prepare for the audits. The second stage fee was $1,200, and the VSE investigated 63 hours to prepare for the audit. Between the first and the second steps, the Brazilian register created an audit report And based on report, VSD performed the recommended corrective actions. So these two steps are performed at different time in 2014. And then after 2 steps, VSD was awarded a 3-year compliance certification for the ISO 9001 standard. So the case was published by a local newspaper. And soon after, a major insurance company awarded a contract for software development at VSE because they are ISO 9001 certified. So 3 years later, the VSE had 23 employees. So this is a case study of how a small company use external audit to get ISO 9001 certified. And after certification, so they have a major contract, and the size of the company increase. So it's a success story. Okay. Okay. Do you have any questions regarding software audits? Okay. So this is about software audits. So now we talk about reviews and inspections and also audits. So these are done manually. So we have experts, like external parties, we have peers to review or inspect the artifacts or to conduct audits. But sometimes maybe we can do things automatically without a manual effort, right? So here, so we talk about the automated code inspection or static code analysis. So some of you may have used them or heard of them, okay? So why? So why we can use automated code inspections or static code analysis? So this is because bugs often repeat. So there are some patterns, for example, developer may forget to check the null values of a function return. This is one pattern, right? Also, sometimes the people may use a single equal in place of double equals. So this is another pattern. So there are many different patterns. These are common mistakes that people may make when writing their source code, right? So because bugs often repeat, so we may use some automated tools to help find such repeating patterns. Okay. So what are the bugs in the real world? So there are many obvious dumb bugs existing in real code, as the examples we just have shown, right? Because of the sheer complexity of modern project, like Java projects. So the potential for misuse of language features APIs is enormous, and those patterns can repeat from one project to another project, from one developer to another developer. If we do simple pattern matching, we can find many bugs. So this is why we have automated tools to analyze the code to find bugs. So there are some general bug patterns. Let's look at some of them. For example, the first is EQ, so which is a covariant definition of equals. So in object-oriented programming, we may define equal for all the objects or for some of the objects. So we may have a bad practices when define such equal methods. Okay. And under HE. HE means equal objects must have equal hash codes. So this is another bad practice, right? So there's for the definition of a more bug patterns, there's a link. You may check this link, right? So we don't go to other examples, but we want to look at the actual tools that we may use. Okay. So what is a static analysis, right? So we use automated tools to analyze the source code to find those bad practice, those bad patterns. Okay. This is an example of using find bugs to find the bugs of JDK 1.7. The find bugs is a static analysis tools for Java. So here we apply find bugs on the JDK 1.7 software product, and we can see that there are a list of bugs, right? For example, for each package, we have the number of bugs found, and we have different patterns of bugs. Okay, there are several categories of bugs like defined by find bugs. The first category is a correctness bug, which is a apparent coding mistake result. For example, when a double equal should be used, use a single equal. That's a correctness bug. So this will result in wrong code behavior, right? The second category is a bad practice. So there may be violations of recommended and essential coding practice. So there may be some standards. For example, you should always check the return values of some function calls, but if you don't check, so you have violations to these practices. So you're having bad practices. They can be detected by the tool. Okay. The third category is doggy, which means sometimes you're writing confusing code. And you're writing code that is not easy to understand. Okay. This is another category. And also on the website, you can see detailed explanation of these categories. Let's look at some detailed bug patterns. So in last slide, we look at the categories, but here we look at some detailed bug patterns. The first one is called BC. The code is BC. What it means? It means equal method should not assume anything about the type of its argument. So we define an equal method for our objects, and we shouldn't make the assumption about the type of the input. We should simply return false if O is not the same type as this. So if we find there's a violation of this rule, so this static tool can give a report. Okay. The second is a BIT, right? Is a check the sign of bitwise operation. So bitwise operation is so you want to do the bit operation such as and or such actions on 2 bit vectors, right? Or just 2 bits, and you shouldn't apply. You shouldn't check the direction or check the sign of the results of the bit operation results. Because if you check if you check the sign, if you use equal, if you, for example, here you calculate the AND operation of two bits, and if you use if you evaluate the result by applying greater than 0. So there might be a problem. You should use a not equal to sign, right? So in this case, if you made this by practice, maybe labeled by the FindBug tool, okay? So these are just some examples. And if you want to go to the details of these examples, so you can go to this link at the bottom of this page, okay? So we talk about the FindBug tool, right? So there are many different static analysis tools. For Java, we have FindBugs, we have PMD. For C and C++, we have CPP check, we have a lint, we have static analysis tools for other programming languages as well. Okay. So if you want to check the tutorial of static analysis tool, you can just go to the web page of this tool and check the menu. Okay. So there's a question: is automated code inspection static or dynamic VV? So any of you want to give an answer for this question? Okay, so next we will have some exercises, and we will also review the exercises from the last class. But before we go to the next part, let's have a break for 5 minutes. Okay, so we will come back at 2:35. Okay, 2:35. We'll come back, and also think about this question: is automated code inspection static or dynamic? Okay, and I'll give the answer after the break. I'll see you at 2:35. Okay, see you later.
I just wanted to stress that 3 students has confirmed it will be a static about your answer.
Sorry?
And three student has said that it will be static, the answer of these questions.
Yeah, that's right. So the automated code generation, code inspection or static analysis, they are static VV, right? Because we don't run the code. We use some tools to analyze the code, to analyze the program without execution. So they are static inspection. Thanks. So I'll see you 5 minutes later. Okay.